Graphical representation of motion along straight line. Along straight line. So with the help of graphs, we can define the type of the motion. We can define the position, velocity, and acceleration. Different things we can define. So first we will discuss the displacement time graph. Displacement time graph. Displacement time graph. So before displacement time graph, I want to tell you one thing. We will take two axes. We will take two axes. Like this. This axis is y-axis. This axis is x-axis. So what is the meaning of the graph? The meaning of the graph is the relation between the variable on y-axis and x-axis. So these variables can be time, velocity, distance time, acceleration time, momentum time. Okay. So displacement time, in displacement time graph, on y-axis we have displacement, on x-axis we have time. On y-axis we have displacement, on x-axis we have time. Okay. So first type of displacement time graph. So I will represent displacement with S and time with small t. So first type of graph we have is this. This type of graph means this type of graph we have, means the graph is lying on the time axis only. So now in this graph now, for different value of time, suppose you are taking the different values of time. Suppose you have taken the time t1 here, here you have time taken the time t2, here you have time taken the time t3. Now time is changing, but the displacement is 0. Okay, you can see this is the origin point, and displacement remains same, and that is 0. So for this graph, from this graph, what you can analyze that the displacement is 0, for any time. Time is increasing, but the displacement remains 0. So what can you say? What is the example of this graph? Means this motion, time changes, but the displacement is 0. That is, the body should be in rest or with no displacement. So you can conclude that the body either is in rest, the body is at rest, rest. Okay, fine. You can write body is at rest. At rest, it is possible always time changes, but the displacement will not change. Displacement will not change. Now another type of graph we will discuss. Another type of graph. This is the first type of graph. Second type of graph we will discuss. So here the displacement and here the time. Here the displacement, here the time. Now this graph is like this, something different like this. Now this is the origin point, and you can say here, see the graph. Initially, this is the time t is equal to 0. This is the time t is equal to 0 means the initially. T is equal to 0 means initially. So initially there is some value of displacement, that is suppose S1. So this value of displacement will be there. So initially there is some displacement, and as the time is changing, suppose this is T1 and after time T2 and after time T3. So we will check whether the displacement is changing or not. So for time T1, the displacement is same. For time T2, the displacement is same. For time T3, again the displacement is same. So displacement is not changing with time. Okay, so what does it mean? So you can say the displacement is constant and do not change with time. You can say the displacement is constant. Constant displacement, na? This line is represented a straight line, means there is only one value, that is S1, and that S1 is only S1, that is constant. Displacement is constant and does not change with time. Does not change with. So can we relate this example with the real life example? So we can say that initially the body has performed, or body have done some displacement. After that the body is at rest, because if the displacement is not changing with time of body, then it will be at rest. Means after certain displacement the body is at rest. So you can just say after some displacement body is at rest. Is at rest. Okay, so these two type of graph first note down, then we will discuss another type of graphs. So in the first graph the body is at rest completely, but here the body has performed some initial displacement, and after that the body uh, came to the rest. So please write down. So in your syllabus the graphical representation is given, that is why I'm just considering it.
Okay.
Write down properly.
Yeah. So can you scroll down?
Yeah. Here na, O is the origin. O is the origin. What is the meaning of origin? Origin is the starting point or the reference point from where all the measurements we are taking. Origin.
Okay. Sorry, can you scroll down?
Yeah. Done.
Almost. I just need to write
Okay.
last
Okay.
time.
Okay. Fine.
Okay, sir, I wrote it down.
Okay. So after this, first we will discuss slope and then we will discuss the another type of graph. Do you know about slope?
Little bit, yeah.
Okay. So if there is a graph like this, suppose like this also, it can be another type of graph. If this angle is theta, then slope of the, suppose this is the displacement time graph I am taking. Okay. So slope is equal to s divided by t. What is this? What is displacement divided by time? Slope is displacement divided by, what is displacement divided by time is velocity.
Hmm.
And this slope is also equal to tan of theta.
Hmm.
Now this tan theta will remain same. This theta is not changing now with time. Theta is not changing. Theta is constant here. So slope is constant. Slope is constant. If slope is constant, then you can say the slope of the displacement time graph is constant, and you can say the velocity is constant. If this if this is a type of graph you will have, then you will say the velocity will remain constant. Velocity will remains velocity will remain constant. So basically slope is the velocity. So if slope is constant, then velocity will also be constant. Okay, so taking one example. This will be the graph number 3rd, I think. This is the graph, and this angle is suppose 30 degree. Okay, and this is the displacement time graph. Okay. So for this graph, what we can say? First, we will calculate the slope. Slope of this graph is equal to tan theta. And what is theta? Theta is 30 degree. So we will put tan 30 degree. And tan 30 degree is 1 by root 3. So this 1 by root 3 thing is constant. So slope is constant. Slope is constant. And what is the slope? What is the slope of the displacement time graph? Slope of displacement time graph is also velocity. So means slope is constant means the velocity is constant. Velocity is constant. So if someone is giving you this kind of graph and saying what is the type of the motion? So basically in this graph, you can say that the body is moving with a constant velocity. What is the meaning of constant velocity? If the velocity is constant, means acceleration is 0. Okay, acceleration is change in velocity divided by change in time. If change in velocity is 0, that is why acceleration is 0. Means this is the uniform motion. This is the uniform motion. The body is moving with uniform velocity. Okay, acceleration is 0. The body is moving with uniform velocity. So you can just write here the body is moving with uniform velocity. Suppose if the graph is like this, this type of graph you have, and this angle is given as this angle is 60 degree given, and this is the displacement time graph. So what can you say about the motion? What can you say about the motion? Now see the initial point t is equal to 0. T is equal to 0 means initially there is some displacement.
Yeah.
There is some displacement. So you can say initially some displacement. Initially some displacement by body. Initially some displacement. Now after that you can say now calculate the slope of the graph. when you will calculate slope, and slope is the velocity of
Yeah.
displacement time graph, and that is equal to tan theta, and tan theta is 1060 here, and 1060 is root 3. So this root 3 is constant now. So slope,
Yeah.
slope is constant, or you can say the velocity is constant. Velocity is constant.
Hmm.
So what is the conclusion of this graph? You can say the body will have some initial displacement. Okay, body
Hmm.
has some initial displacement with uniform velocity, or you can say body has uniform velocity, uniform velocity with some initial displacement. Okay, so please you can note down the slope is very important part for the
Hmm.
graphical purpose. Slope is very important, means how to find the slope we should know for the study
Yeah.
of the all kind of graphs.
Hmm. Sorry, can you scroll down? Sir, can you scroll down?
Just wait. Done? Rayyan?
Not yet.
Okay, fine. Right, please write. No problem.
Okay, sir, I wrote it down.
Okay. So now we will solve one question on it. Two questions. Very good questions. We'll take. Two graphs are given. One graph is like this. Means first graph is like this, passing from the origin, and displacement time graph. This is this displacement time graph, and this angle is the 45 degree. And there is another graph, and in this graph where this angle is 45 degree. And remember, I am writing here what is 1045. 1045 degree is equal to 1. Okay, 1045 degree is equal to 1. This is graph number 1, and this is graph number 2. So options of four options are given. You have to find the correct option. both. This is a graph for a person, motion of a person one. Okay, person, or you can say body one. This is body one. This is for body one. This is for body two. So both body one and two will have same velocity. Option B, both body 1 and 2 will have different,
displacement.
no, different velocity. See, both have same initial displacement. Actually, these are the part. This is the part of the question. These are the options. You have to choose the correct option.
Oh, okay.
Both have same initial displacements. Both have different initial displacements. Now you have to choose, means two options are correct. Out of this force, two options are correct, and you have to choose the correct options. So just try, means what I told you, just try once, then I will solve, no problem. And again I'm telling, this is the displacement time graph. Both are the displacement time graph. This is for body 1. This is for body 2. And I have given the hint. No, 1045 is equal to 1. So go to your notes and see, try to apply your mind, and then we will solve it.
Velocity is constant, and both have different initial displacement.
Means which options are correct?
So A and D.
D. Very good. Right answer. Very good. Rayyan. Now you can see how this is. Now see, this is the initial point. This is the initial point. So initially, this has zero displacement. One has zero displacement. But the second half has some displacement. So from this, it is clear that option D is correct and option C is we have removed. Now, what about the velocity? I told you that for the velocity is the slope of displacement time graph. Now calculate the velocity for one body. That will be the slope for the one body. And what is the slope? Slope is the tan theta. Now calculate V1. When you will calculate V1, you will calculate 1045. 1045 will give you V1.
Yeah.
So 1045 is 1. Now when you will calculate V2, again you will calculate 1045. So mean again you will get 1. So velocity is 1 units. So both have the same velocity. Very good, Adrian. Okay, so please write down, and I will say this question is good for you. Please write down.
Okay.
So this is means the study of the graph means you should know what the slope is going to give you. Then we will understand properly means what the graph is saying. Oh, sorry. Here will be time, okay? You can change it by yourself.
Okay, so I wrote that down.
Okay.
Okay, so I wrote it down.